All right, hello everybody. Welcome to Near the Backend. We're going to be demoing containerization. So we're going to kind of start from where we started last week or 2 days ago. Let me put this up here. And I'm going to try to go like a bit slower and like explain things a little bit better. So we learned 2 days ago on Monday that um, Docker is a good way to have like your code files and put it in like a container to be isolated from, say, your system specifically. So you put like a Docker image of your code onto a container. People can pull your container or pull your image and then run your image to make a container. And they don't have to have like the same system as you, since your Docker image tells their computer how to actually build the container. So if I had like my P4 like right here, crazy example, and I wanted to share this with a friend who wants to run on their computer, I could just put this on an image, run the image, make a container, and then I could send them the image. And since the Docker file tells the Docker file tells the image how to build the container, they can build the exact same container with the image as I do. So there's no weird multi-platform issues because we're running on Docker and not like if I have a Mac and they had a Windows. So that's why Docker is pretty useful. And Docker has like three main things about it. The first thing is like images. Like we said on Monday, it's like a snapshot of the code. And that's if we run images, we were able to create a container. And a container is kind of like a process of how to run a process of the running virtual operating system that is running the specific code or multiple like programs that your image specifies. And we also have Docker Hub. I can show you what Docker Hub looks like. So this is Docker Hub. It's kind of like GitHub for Docker images. I have a few of these. These are from when I took the course. And yeah, you can pull and push your images, and people can pull them from there and then run them like they had as if they made it themselves. So yeah, so you have images of containers, and you can push those images to Docker Hub. So let's start again from scratch. Say we have our PA4 and I want to actually just put it on Docker Hub and run it as a container. So first step, you want to make a Docker file. And actually, that's not the first step. So if you're like running on a Windows or a Mac, you probably can't make Docker images. Like if I try to say Docker images, it says that it can't connect to Docker, I think daemon, because I didn't run my Docker program. So for like Macs, you have to install this Docker thing so that it actually runs the Docker service on your laptop. And I just wanted to show that off by not running mine until I came here. So I gotta wait for that to load up. And once it finishes loading, you can just use Docker on your terminal. But in the meantime, I'm gonna make the Docker file. So to make a Docker file, it's just capital D, oops, not just capital D, but this Docker file, no extension, and that's just it. I need to delete this other file that I made. Yeah. So first, when you make a Docker file, you want to specify like what it's running on. So you just say from, and we want to use Python. So we'll just say Python 3.9. And this is a base image. As you can see here, it just has, this is a base image that's built upon that we can build on top of. And this one comes with Python. And we want to have version 3.9. There are other versions, but this one I know exists because I tested it out. But I think you can look them up and see what other ones exist. Okay, Docker has finished loading, so I'm going to put this in the background. Okay. So now once we have our base image, we want to tell it to like create one of our file directories to actually put the code in. So saying run, you can say mkdir, and then user/app. And this will just run this command in the Docker terminal, like your container's terminal inside of it. And it will create this directory user/app. And now we want to copy our actual codes files into there. So the code I want to get is in my current directory. So I can just say dot, and I want to put it into, oh, before you can do this, you can't actually do this quite yet. We want to specify our working directory. So first you want to say work dir, and then we want this to be the one we just made. So user app. So now we're working in this file system or file directory user slash app. And we want to copy our code into that file folder. And since this is our working directory, this is where we start off in. So we can just say dot, and that should be right. Let me see. Okay. Next, we want to actually install our Python modules. So you can say run, and then like you usually do when you have to install modules from a requirements file, you can say pip3 dot install -r requirements .txt, and run just, yeah, run runs this function or this command. And you might be noticing that we don't actually create a virtual environment like we would on our laptops. And that's because Docker containers are isolated and usually only used for one program at a time. So you don't actually need to isolate your modules because there's only one thing that's running in there. So it doesn't have to be put into a small environment. We can just install it into our main one. So you don't need to make a virtual environment for this. Now we can say cmd or command, and then run our Python script app.py, which should run my server. And I think the issue last time we were having when it was like breaking was that I just said Python app.py, and I might have been running Python too. So yeah, question. Yeah, so you can say run multiple times in a Docker file, but you can only say command once. And it's usually like for the last thing you want to run, sort of the thing that's like causing the container to do what it's meant to do. I think there's another one called, actually don't remember, but yeah, running is usually made for building the environment, like making the directory, installing the requirements and all that stuff. And command usually used for running the main function you want to do. And okay, that looks like a good Docker file. And this should copy everything in this current directory called starter. So app.py, db.py, requirements. It won't copy itself, but it'll also copy the virtual environment and the PyCache. And we don't typically want to have those in our images because it'll make our images really large. So we can say docker ignore. Yeah, didn't make it. And this file will tell your Docker service to ignore certain files, kind of like a git ignore. So I want to ignore the then folder and the iCache. Okay. And so it'll look like that whenever I try to make the image and then just not put them in the image. So now I'm going to make the image. So Docker build, and I want to have a name. So repository will be KZEG, which is my first letter, last name, and then /demos. So that's where it's going to go if I were to like push it to Docker Hub. And the tag can be v1. And then the location of my Docker file is my current directory. So I'll just put a dot there. And then while this builds, probably gonna take a lot of time because my laptop's not the best. It's also kind of low on battery. So while this is building, does anyone have any questions about anything so far? It's actually running kind of fast. Yeah, it's yeah, it can be anything you want. Like if I go to Docker Hub, I have one called Final PA5, like 5. And it's kind of like making a repository in GitHub. So you can name whatever you want. I think it might have to be unique though. Since it starts with like your username, it tends to be unique, but you probably can't make two finals. But yeah. So if you make an image, oh yeah, question? Yeah, because the Docker service that's actually doing these functions, like reading like building the images, running them. So you do need to have Docker installed on your computer. One cool thing about building images is that if you build it once and you were to rebuild it, it actually caches most of the work. So like this part was cached, which makes it run faster. But since I have not made this image before, it has to do a whole thing over again. So so how's it going with the PA4? Going well. Be open to asking questions after the lecture if you guys want. So if anything's any issues on PA4, you can just ask us. I don't know what else to talk about right now. It's taking a lot of time. Yeah. How do you clear the data? You mean like in PA4? Yeah. You can just delete the SQLite DB file. Yeah, because it shouldn't remake it. So if you need to change the file, the columns to do that. Do you have a question? Oh, we'll do that later, like after this demo. Okay, so it did finish building. That's good. So now I want to run the image, make it into a container. You just say Docker run. A good thing to do when you do this is put -it. This puts it in interactive mode. So that means you can interact with the container and it won't just do its own thing. And then we want to put in the repository name, so kzeg/dem. Oh, I'm gonna put this. I'm gonna go to the terminal and do this, so it's just easy to see. So if I go to Docker images, see if it's here. Yeah, it's my image is right there. So it was created. So I'm just gonna say Docker run -it or interactive mode kzeg dmls v1. Hopefully this works. So now I should be building the container and then running my Flask server. And as you see here, it does start running. And if I try to go to this URL, it's probably not going to work because I didn't expose the port. So if I try this out, yeah, it didn't reach the server. So in order to do that, you want to actually run it with ports flag. So -p, and you want to specify what port on your computer is going to be, well, what port on the server, well, the container is going to be forwarded to the port on your computer. So I want to forward it to port 5000. And if I look at my code, let me see. I can just look here. It's running on port 5000 in the container. So then I'll put :5000. Oh, how am I doing it here again? So I'll close this with Control-C. It could work. Because because it's an interactive mode, I can close the container, Docker PS. And you can see it's not running anymore. So if I go back and run it with the P flag, the ports, I want port 5000 in the container to go to port 5000 on my computer. If I run this, a second. Okay, now it's running. Let me go back to my browser and then try to go to this port on localhost. Well, it is connecting. I think my code has a bug in it, but I was able to connect to my server, which is probably all I wanted to do. I don't think there's like an endpoint to this, but you can see here I'm connecting to the container, and that's pretty good for now. One thing you will want to know how to do is see what containers are currently running on your computer. If you say Docker PS, this will show you all the running containers. So you can see here, this one is currently running, the one I just made. It's been running for 55 seconds. And if you do Docker PS -A, this shows you all the containers, even the ones that have exited. So if you have like a container that's being buggy and like crashing, just do Docker PSA, then you'll be able to see which ones have exited, and then you can debug from there. All right, let me see now. So there is another way to run, yeah, what's the question? You can say, let's see, you have to use like Docker PS when you leave interactive mode. Let's say this one is running. It's not interactive mode, so I can't close it, right? So this is kind of important. Okay, I think it's probably running. So if I say Docker PS, you can see that I just started running it, but I can't close it with Control C because it's not interactive mode. So you can do is copy the container ID here. This will allow you to say Docker RM container ID, and that should remove the container. That doesn't work. No. I think it might be Docker kill actually. If you say Docker kill container ID, that should kill the running process. So maybe Docker PS. It stopped. So you have to actually find the ID and kill the process. So the other way to make another way to make containers and run multiple containers in one file is by using something called a Docker compose file. So the way to build this is by saying docker-compose. And it does have a file extension. It's YML. So it's like a YAML file. And the thing about YAML files is like, they're kind of like JSON files, but like they require precise spacing and not curly braces. So it can be annoying in that way. But we can actually, with this file, run multiple containers at once, but we're going to try out only one right now. So the first thing you want to say is the version of Docker Compose you're using. I spelled version wrong. Right now I'm going to use version 3. And to define the containers you're going to make, you say services. And then you need like 2 spaces or just tab. And now we can define the services I want to run. So I'm going to call my first one demo. And then define like what image this container is going to use. You say image, and then this is where the repository name comes in handy. Say the image repository, so Kazagay, demos, and then v1. And then you know the issue with like being unable to access the port. The way to solve that in Docker Compose is by specifying the ports. And then you need a dash because it's a list of ports that you can put in. So like my first one, I want to do 5,000 to 5,000. And since some products can be really complicated and have multiple ports running, and then you can have multiple ports in this list. So like I could say like, I think 8,000 to 5,000, but we only want one for this one. And a reminder that the one on the left, the one on the right is the port in the container, and the one on the left is the port on your computer, or the port being exposed where it's being forwarded to. So if I said 8,000 here, I have to go to localhost at the port 8000 to access my container. And that's honestly kind of it. So this is a very simple compose file. And the way to run it is by, first you have to actually go to the directory where it's found. So let me find that where there is a pwd. Okay, now I'm here. My Docker compose file is in this directory. So the way you run a Docker compose file is all you gotta say is docker dash compose, and then up, and that'll bring up all the images in your compose file and start running them. Oh, that's awkward. So version must be a string. I will follow that. Probably want to make this a string too. Okay. Run that again. Now you can see it's starting to create the container created, attaching. So it's doing stuff in the background right now. And yeah, so now my server is running with the compose file. You can see here, and then you can still connect to it via the port, although I think I did change the port. So I had to go to 8000 this time. And yeah, so this is just a second way to run your images. One issue is that once you do this, you can't actually use your terminal anymore. You can still control C to stop it. Or if you go to another terminal, you can just take it down by saying docker compose and then down. So if you do that, that'll also take it down. But I think I just click control C and it's also doing it. So you guys can do whatever you want. One important thing to know about using Docker Compose is that if you don't want to hog your terminal, you can say -d at the end, and that'll run it in detached mode. So it'll run in the background instead of making you unable to use your terminal. And now you see I can type stuff again. And if I want to, I can do Docker PS. I can see that my container is running. I say Docker compose down, it goes down. So yeah. So one thing that's important about sharing code is that you don't want to expose like sensitive things like what do you call it, API keys or passwords or anything like that that are required in your code files, but you don't want to show to people who want to see your code. And so the way you want to actually do that is what we said on Monday through environment variables. So the way you typically do environment variables is by creating a new file in your code directory, just making a .env file. In here, you can define a bunch of environment variables that you want to save. So I want to have like my name. It's going to be Caboose. I'm going to save my net ID. It'll be KMZ25. And you put other secrets in here. And so if you were using Python, you want to save like your environment variables, or you want to use them, you should import OS. And OS is the, let me delete some of this stuff. OS is the module that allows you to access your environment variables. So the way to do that is by saying, let me put this down here. os.environ. And this is just like a dictionary full of the environment variables in the computer. I say name, I get my name, and so on. And let's actually demo doing this Docker. So I'm gonna make a new endpoint called greeting. So this will be called define greeting. And this is just gonna return my name and net ID. So return hello and os.environ name. Should make this single quotes. And then I'll also put in my net ID. And if someone is like pulling your code from GitHub, this is all they're gonna see. They're not actually gonna see your actual the values of these environment variables, as long as you don't like push your env file. And the way to actually put these env files in your computer, you have to use some module, either like dir-env and .m, and they'll load them onto your computer. But the reason why env files are useful for Docker is that with a Docker compose file, you can actually load in those variables onto your containers. So if you are in your compose file, you can say env file, and you can specify .env as the file for environments, and that will load in the .env file, because that's also going to be put into our image, since we're not ignoring this file with my secrets in it. So let me just rebuild my container or my image, Docker build. Now it's also going to include my env file as well. This shouldn't take this long. Does anyone have any questions so far while this is building? Maybe on like env files, why we need them, how we're loading them. Yeah. Yeah, because it's in my current directory, and it's also not in my Docker ignore, so it should be included as well. As far as I know, on Docker Hub, they don't actually see the code files. If I go to like this image that I pushed, go to the latest. This is what they see. But in the case that you like don't want them to be able to run your image and have access to those variables, what most people would do is store their env file onto like, oh yeah, you're right, probably. They would store it onto their server online, and then it would pick up on that, which I think is what it's supposed to do. So yeah, I do not want to include it. So let me do this. Make sure you actually don't include the env file. So putting that on your Docker ignore, you cancel the build on this. Yeah. Yeah, that was right. So make sure you actually don't put that in your container. That will go in the Docker Hub. And then they'll be able to run your code as if they have those env files. They won't be able to like see them unless they go into your containers code, but you wouldn't want that anyways. So if you were to like pull someone's image and you need to run it with these env files, you have to ask them for the actual file. And then when you run the container or the image on your computer, you should have the env file in your directory where the Docker Compose will actually pull it from there. So yeah. Any other questions on this stuff? Yeah. Not really sure on those specifically, since I've never really done it before. There's probably a way to store it on there in like their own framework. I'm not really sure. If you have like on AWS a running virtual machine, you'll probably want to just put the env file onto the virtual machine. And then if you run the container in there, it should be able to get it from there as long as like just like it is doing now from my current directory. So yeah, we're gonna be using I think Google Cloud in our next demo for actually deploying this stuff, and you'll have to do that in there as well. So that should be pretty similar. Yeah. The first port's the one in the container. So if you have your Flask server going to port 5000 in your container, this will route that port to outside of the container, and you can access that via port 8000 on just your computer. And you can just route it to the same port. It's mainly to like make sure you don't have like ports overlapping on your computer. That's taking longer than before. I think on most other laptops, it should probably be a little bit faster. Okay, there we go. It's done. Or almost done. Okay, cool. It's finished building. I want to actually show off pushing this to Docker Hub. So I have this cool new image. I want to put it on my repository. Just say Docker push, type in the name of the repository and the tag. You will need a Docker Hub account to actually do this. Say Docker login. I think I've already logged into mine. And then it starts pushing it. Hopefully this works out. Okay, I did not log in. I'm probably not going to log in here. You just say Docker login, and it'll tell you to type in username and password. So yeah, now I'm going to run this Docker compose up. Let me make sure that the Docker compose file is up to date. Okay, it is. I'll put it in small mode. Hopefully this should have the new endpoint I just made with my first name and like my net ID. And I could show off that working. No, that's so annoying. I forgot. This should be a single quote. I have to rebuild it. Make sure you test your code locally before you make it in an image, or else you have to rebuild it again, like what's happening right now. Okay, okay, it's done. So let's try that again. Docker compose up. Now it's building the container. Okay, it actually ended up working. Okay. So let's see what happens if I connect now. So as you guys can probably not see because it's so small right now, going to the base endpoint prints out my name and the ID. Those are my environment variables. So the container was actually able to access those variables. So that was fairly good to see. I just made this small endpoint here to show that off. So yeah, does anyone have any like questions about this whole process and like why this part is a little bit significant? If not, we can probably just move into the Kahoot. So yeah.